Hello there. Welcome to the first lecture of week 12. If you remember, in week 10, I had taught you about testing web applications and testing object-oriented applications, system-level testing of object-oriented applications. This was the outline of how I began. We saw overviews of features of object-oriented software, some of which were done in the middle of the course. Then we saw an overview of all kinds of errors or anomalies that can occur in object-oriented software, especially during integration testing of object-oriented systems. Then we also saw what is a yo-yo graph. What I had not done as a part of those lectures was to do object-oriented call coverage criteria specific to integration testing. In week 11, I decided to drop object-oriented testing without doing this and give you an overview of symbolic and concolic test selection techniques, mainly because I wanted that to be a complete set of 5 lectures covering 1 week's details. So what I will now do is catch up on what I did in week 10 and finish object-oriented testing. So to recap, we saw all the features of object-oriented software: abstraction, inheritance, polymorphism, 2 kinds of inheritance, what is a polymorphic method, which is the level of object-oriented testing that we are going to do, which is basically interclass and intra-class testing, and the problem of difficulty in visualizing object-oriented interactions in the presence of class hierarchies and overriding methods and polymorphic methods. And we also saw this yo-yo graph, which depicts how object-oriented interactions occur. And in week 10, I had also introduced you to the various kinds of object-oriented faults: state definition anomaly, state definition inconsistency, state visibility fault, all other kinds of faults. And then what I didn't do is the last part, which dealt with coupling variables specific to object-oriented software. How does data flow work in the presence of coupling variables, and what are the object-oriented specific coverage criteria that we would see? So that's what I'm going to do in today's lecture. Coupling variables is not a concept that is new for us in the course. We have seen coupling when we did design integration testing. Coupling variable is a variable that is used in one and defined in one module and used in the other. But now the problem is, in object-oriented software, how does a coupling variable occur? There could be a pair of method calls within the body of method that is being tested. This pair of method calls can be made through a common instance of an object with respect to a set of variables that are commonly referenced by both the methods, and it consists typically of at least one coupling path between the 2 method calls for one state variable. So these represent potential state space interactions between the called methods with reference to the calling method. So we have to identify which are the points of integration and what are the testing requirements in terms of coverage criteria for us to test on. So we'll look at the various kinds of definition use pairs that we have seen till now. This is one thing that we saw right in the beginning when we did data flow testing along with graphs. Within one method or a procedure A, a variable can be defined and used. So this is intra-procedure or intra-method. Within a method, normal kind of definition use data flow. This we saw when we did data flow coverage criteria during graph-based testing. The next is inter-procedural data flow, which is from one procedure A to another procedure B. A particular definition happens in A and is used in B. If the definition happens to be the last definition in A and the first use of a particular variable in B, then such a variable is called a coupling variable, and we consider coupling data flow. Now, when it comes to object-oriented data flow, what we're talking about is instances of these A and B and definitions occurring in the instance of A and in instance of B. This is direct object-oriented coupling. In indirect object-oriented coupling, what happens? There is a method M, there is another method N, there is a method A that uses M, there is a method B that uses N, and the definition and use happens in A and B for M and N. So we'll see examples where this becomes a little more clear. So this is again a recap from the earlier lecture. What is a last def or a last definition? It's a set of nodes that define a variable x and has a def clear path from the node through a call site to a use in the other procedure or module. That can be from the caller to a callee, or can be from a callee back to the caller, in which case it's the value that is returned. What is the first use? It's a set of nodes or statements that have uses of a particular variable y, for which there is a def clear and a use clear path from the call site to the node that contains this use. This is what we saw long ago when we did design integration testing. And this, if you remember, is an exact recap of an example that I used in an earlier lecture. There is a procedure F that at some point in its code calls another procedure G, and it calls G with X. The value that G returns is passed to Y. So this statement is what is called the call site. This the definition of X that occurred just before this call is the last definition. When it's passed, it becomes the first use, and some calculation happens, and the value that is returned, the statement that is causes the value that to be returned, is what is called the last definition. So this is what we saw as last definition and first use. Now we'll see the same concept but with reference to object-oriented testing. So to understand that, we first need to understand, when we have polymorphic methods, what is a polymorphic call set. So here, in the presence of polymorphic methods, the first thing to observe is that the definitions and use for such coupling variables like these can be indirect. So what do we mean by indirect? Indirect means you don't know which version will be executed in which method that is being used. So in the presence of indirect definitions and uses, we have to consider all the methods that can potentially execute. So polymorphic call set is the set of methods that can potentially execute as a result of a method call through a particular instance context. I'll illustrate it with an example. So this is a slightly big figure, but we'll go through it slowly. On the left hand side is what we have, the class hierarchy. There are 4 classes, W, X, Z and Y. W has 2 private variables, V and U, 3 methods, M, N and L. X has a variable small x, a method N again, overridden. Z has no variables that matters to us for now, so we will ignore the other variables that don't matter to us in Z. I have not depicted it. And Z also has 2 methods, M and N, and Y has a local private variable W and 2 methods, M and L. Please remember that M occurs here, here and here, and N occurs in W, X and Z, and L occurs in W and Y. So here is a typical code that uses this class hierarchy and the methods from these various classes. Let's say it's the code of some client F. So there is an object O. Let's say now that O is bound to an instance of the class W for our example in this code. So what happens now, let's say at this point the method M is called in O and M is executed. If you go to M let's say defines V. Now remember, object is bound to an instance of W, so it's W's definition of V that is used and passed back. And then moving on. So how do I read this figure? What is the legend? These white ellipses are method entries. These black ellipses are method exits. So there are method entries here, here and here for M, L and N. There is a main method entry here and method exit here. These black circle ones are call sites where the method calls happens, and the white circles are when the method finishes executing, it's the call return. So from this figure, I hope it will be clear. So method M is called, which defines V and the value is returned. Then the method I is called, which defines U, and then the value is returned. And then the method N is called, which defines, which uses U. And then let's say it also uses V and it's returned. So this dotted dashed lines and the solid lines represent the coupling sequence of variables and the call sites and call returns. This happens for this class hierarchy when the object O is bound to the class W. Let's say an object O is instead for the same class hierarchy is bound to an instance of the class Z. Then what happens? right up front, when this client calls this method I, instead of taking W's definition, let's say Z's definition of X is taken. We have introduced the variable X that matters to us in Z. And then let's say the next call, W's definition of U is taken because L does not belong to Z. And then X's use in Z is considered, and X's use in Z is again considered here. Right? So in which case the problem is because Z doesn't have an instance of L, W's L is considered, and it could cause the coupling sequence being different. There is branching here which didn't happen here during the use. When we come to object-oriented coupling, what are our testing goals? We want to be able to test the following. We want to test how a method can interact with an instance bound to an object O. Like for example here, an object O is bound to an instance of W. The interaction is different from when an object O is bound to an instance of Z. And we need to consider the set of interactions that can occur, what are the types that can be bound to O, which are the methods that can actually execute in the presence of polymorphic call sets, and we have to test all couplings with all the type bindings. So we define 4 coverage criteria. The first one that we will look at is what is called all coupling sequences, abbreviated as ACS, where for every coupling sequence Sj in the particular method f, there is at least one test case T that needs to be written such that there is a coupling path induced by Sjk, which is a subpath of the execution trace of f when it's executed in T. So what it said is that there is a coupling sequence Sj, for example, like this kind of sequence, what is coupled with what is coupled with what is coupled with what. Every dashed line is coupled with the following bold normal line. So for every such sequence in F, there is at least one test case that we must write such that when you execute the test case, the coupling path comes Sjk, that should be a subpath of the execution trace when F is executed with T. Which means what? At least one coupling path must be executed. Let's say there are 3 coupling variables. All it says is that per variable, please execute at least one coupling path. No inheritance, polymorphism, polymorphic call set, it's not considered in this coverage criteria. The next is all poly classes, abbreviated as APC. Here, for every coupling sequence Sjk in the method f, that's the same as we saw here. And for every class in the family of types defined by the context of Sjk, there is at least one test case T such that when T is executed on F, there is a path in the set of coupling paths that is a subpath of the execution trace of F of T. So what is the difference between this and this? This includes all the coupling variables. This includes all the coupling variables in the context of the call that was made, considering the binding also. So it includes at least one test case for every type the object can be bound to. If we go back to the example, it will include one test case for this case when O is bound to Z, one test case for this case when O is bound to W. And it also tests with every possible type substitution that can happen. Obviously, this is more effective, or it subsumes the all coupling sequences criteria. So the next is all coupling defs and uses. So here what happens, abbreviated as ACDU, for every coupling variable V in each coupling pair Sjk of a test case T, there is a coupling path introduced by Sjk such that P is the subpath of execution trace of f of T for at least one case T. Which means what? Every last definition of a coupling variable reaches every first use. So here it was like at least the first case, here it is every. This is again without inheritance and polymorphism. So obviously the next one is going to be every last definition reaching every first use with inheritance and polymorphism, and this is the mother of all criteria. It includes polymorphism, polymorphic call sets, and it says every coupling variable, every definition to every use has to be covered. Don't worry about this definition being long. What it basically says is, it says that if I have a coupling sequence in a function f, then for every class in the family of types defined by the context of Sjk, consider every coupling variable in that, and then consider the nodes in which the last definition happened and the first use happened. You must have a test case for including that path. That's what it says. So the simplest to repeat is all coupling sequences, which says at least one coupling path must be executed. The next is at least one coupling path in the presence of instance contexts and object binding should be executed. This is every last definition to every first use reachability should be tested without inheritance and polymorphism. This is every last definition to every first use with inheritance and polymorphism and type binding. So this is the mother or the highest coverage criteria, the most difficult to subsume, and by definitions this picture should be very clear. This says that test all coupling sequences, the first one. This says with polymorphism. This says all definitions and uses but without polymorphism. This is all definitions, uses with polymorphism with object binding. So these are the 4 coupling coverage criteria that you can use for integration testing for object-oriented software. So to conclude the object-oriented software lecture, we understood in week 10 yo-yo graphs, in errors and anomalies in object-oriented testing. Today we understood polymorphic call sets, what are the definitions and uses of state variables for integration testing, and also looked at various coverage criteria that will detect faults that come because of object-oriented features like inheritance and polymorphism. So I hope this lecture was beneficial to you. This will bring us to an end of object-oriented integration testing. Thank you.